Hello, geometry people. The reason that we studied proportions last class is because we're going to be using proportions when we study similar polygons. Now, here I'm showing you the comparison between congruent and similar. Congruent, which we've learned already, and there's the symbol, an equal sign with the squiggly line above that is sometimes called a tilde. Then we have similar, which is done, the symbol does not have the equal sign, just the tilde. Congruent means the same shape and size. They're basically identical. Similar means same shape, but a different size. The key fact we want you to know today is that the sides of similar polygons are proportional. Whenever you're doing a math problem and you see similar or you see the symbol for similar, you know you're going to be setting up a proportion. So let's look at these two quadrilaterals. I drew them as close as I could to being similar, but let's actually put in the symbol between the two, stating that they are similar. Now, here it says AB is X, so I'm going to label AB X. BC is 7, PQ is X minus 4, and QR is 5. Now, since these two polygons are similar, the matching sides or corresponding sides are proportional. And you can see the way it's drawn that this side AB matches with that side PQ. So I'm going to say the X is proportional to X minus 4. And the other two sides are going to be in the same ratio. So the BC matches the QR, so 7 matches with 5. And we have our proportion set up. X matches with X minus 4, the same as 7 matches with 5. So now let's solve this by cross multiplying. 5 times X equals 7 times X minus 4. 5X is equal to 7X minus 28. Now here I normally say subtract a smaller variable, but I don't want you to do that because then you get a 0 on the other side and many students will then make a mistake. But if you minus the 7x, you get negative 2x equals, and don't forget to bring down the negative on the 28. So then when you divide by the negative 2, a negative divided by a negative is positive. So we get x is equal to 14. All right. Another type of very common problem is involving triangles. And here we have the sides of a triangle are 4, 8, and 10. If the longest side of a similar triangle is 15, find the shortest side. All right? So let's draw two triangles. I mean, you don't really have to, but I always find it's helpful when I do that in geometry to draw the triangle. Now, the first triangle has sides of 4, 8, and 10. Now, if these two triangles are similar, the longest side of the similar triangle is 15. Well, where am I going to put the 15 over here? Well, the longest side here is 10, so the 15 is going to match where the 10 is. And we're trying to find the shortest side. That's my x. The shortest side is over here, so the x is going to match the 4. And now, when we set up our proportion, we want to have the sides matching. What you're going to find doing these problems is there's a lot of different ways to set up a correct proportion, but there's also a lot of ways to set up an incorrect proportion. You want to make the sides match. So I'm going to match the 4 with the x, and that's going to be the same as the 10 to the 15. I'm not going to use the 8 because there's no side over there. 4 times 15 is 60. Is equal to 10 times x, divided by 10, 6 equals x. So that is the length of the shortest side. Good luck with your assignment on proportions.